Hello students. So today we will continue with our next experiment, that is to study operation of 4 line to 1 line multiplexer, and its second part, 1 line to 4 line demultiplexer. So first we will consider multiplexer circuit, right? So what is multiplexer? In this video I will just tell you about multiplexer, and we will implement only multiplexer circuit, right? So what is multiplexer? A multiplexer is a circuit with more than one input but only one output. Okay, in other words, you can say many into one. Many inputs are there but a single output is taken out. You can check it from the table below. You can see control inputs A and B are used. Okay, that is your select signal, and select input D0, D1, D2, D3. Okay, control input is used with select input. Okay, when your control input is 0 0, then a select input will be D0, and when control input will be 0 1, then D1 will be selected, and at 1 0 control input your D2 will be selected, and when both A and B are 1 1, then input selected will be D3. So you can see that our demonstration board, okay, which we have at in our labs, there are data switches D0, D1, D2, D3, and control switches AB. Okay, LED is there on the demonstration board for visual indication of output, right? So the multiplexer select desired input by applying control signal selected by switches. Okay, switches A and B are used for feeding input, control input, and the basic circuit is an AND OR circuit. Okay, that we will implement uh, in Proteus, because if you see the circuit, okay, that is the 3 input and gate is used, and 4 input OR gate is used. So in the app logic gate simulator, okay, we don't have these components with uh, multiple inputs, more than 2 inputs. Okay, so we will you can use Proteus 8. Okay, or we can complete this by simulation. I will simulate it in separate video, and you can just observe the things, you can just observe the output. Okay, so first we will see that data input D0, D1, D2, D3 is applied to the input of the individual gates, one input respectively, right? And the control signal is also applied to the other inputs, either directly or inverted form. You can that check that. Here we have used control inputs A, B, right? A, B is directly applied to uh, different gates and gates, and their inversion is applied through N1 and N2. That is your NOT gate. Okay, so we will just observe the truth table. Okay, this is the truth table for multiplexer. Okay, your control input is there, your data input is there, and a single output Y is taken. So we have earlier discussed that, you know, sum of product method to get an output expression. Okay, we can write this truth table in an expression form, and that expression we can implement that expression into our circuit diagram. So in sum of product form, as you know, I have told you earlier, in a sum of product form we only consider the input entities for which the output is 1, right? And in product of sum method, the entities which gives output 0 are considered, but in this we will use sum of product method. Okay, so we will first product all the input entities for which our output is 1, and after that we will add them. So here I have written an expression, you can closely observe it. Okay, so just find the entities, input entities for which the output is 1. You can see serial number 1. Okay, 0 0, when the input control input is 0 0 and d naught is 1, you can check output is y. For this we can write it in sum of product form. Okay, we can take it like we have to product these all inputs. So when this product will be 1, when all the entities are written in the expression a bar dot b bar dot d naught. Okay, only that, only then y will be 1. Okay, if we put a equal to 0, then a bar becomes 1. 1 multiplied by, when b is 0, b bar becomes 1. So 1 1 1, it will give us a 1. Okay, so similarly we will consider, we will add other entities, uh, sum of product, we will add sum of product of other entities. So we will product other entities for which output is 1 and just add all the entities and make the output expression true. True means 1. Okay, so by observing serial number 3, 5, 7 and 9, you can see output is 1 for these entities, these input entities, control inputs and data inputs. So just write an expression. So our final expression will be a bar dot b bar dot d dot plus line number 5. A bar, we can write when a is inputted 0, we can write it like a bar. Okay, so a bar dot b dot d1 plus a dot b bar dot d2. This is for serial number 7. This expression is for serial number 7. You can call these individual individual entities which we get in this main expression. So these are called minterms. Okay, minterm, first minterm, second minterm, third minterm, and final fourth minterm. When we add all these minterms, we will get the final expression y. Okay, for which y is true. So last minterm is serial number 9. Okay, when a is 1, b is 1 and your d3 is 1. So what will be product will be a dot b dot d3. Okay, and we are using sum of product, then we need to sum it to the other minterms. So final expression will be like a bar dot b bar dot d dot plus a bar dot b dot d1 plus a b bar dot d2 plus ab dot d3 equal to y. This is our final expression, and now you can clearly observe the expression, output expression. So what we have to do, we have to just implement it in circuit diagram form. Okay, so we need gates. So by closely observing this expression, you can find that a OR gate is used for addition. Okay, so 4 minterms are there, it means 4 input OR gate will be required. Okay, and another gate is used is you can see dot operation there, product. Okay, this product we can achieve by using your AND gate. So how many AND gates we require? We require 1, 2, 3, 4. 4 AND gates are required for achieving ANDed operation, and these are 3 input AND gate. Okay, 3 input and single output. Okay, output will be single, but input can vary depending upon your output expression, depending upon your min terms. Okay, so 4 AND gate are required and 1 OR gate is required, and any other gate. Okay, you can check a bar, b bar is also in the expression. So how can we get a bar, b bar? This is just a complement, so we need to use a inverter. Okay, we can use inverted inverter for inverting the input control input a and b. So our final circuit will be like this. Okay, you can check here, data inputs d0, d1, d2, d3 are there, and your control inputs a, b is also applied directly or in inverted form by using n1 and n2 NOT gate. Okay, so when your control input is 0 0, okay, these are the possible combinations I have written in the tabular form. You can just check it. When your AB is 0 0 and your D0, D1, D2, D3, these all are 0, so output will be depending upon your control input 0 0. Okay, but your D0 only, your select line, select input D0 will be appear presented at output. Okay, you will get D0 at Y. When you check Y, okay, during your implementation, okay, in your simulation, then you will find that for AB 0 0 and only D0 will be selected, okay, and appear at output. When our D0 goes high, so we will get a high output at Y. Okay, and for other combinations, our all gates will be false. Okay, none of the AND gate will be true. Okay, for other data inputs. Okay, like when D1 is 1 but control signal is 0 0, D1 will not be at the output. For D2, it will not be presented at output when control is 0 0. When D3 is 1 and control signal is 0 0, D3 will not appear at output. Only your select input D0 will be at output for control input 0 0. Similarly, you can check it by, during simulation for all combinations of 0 1. Only your D1 will appear at output. Okay, and for control input 1 0, your D2 will appear at output. And similarly, when the control input is 1 1, only D3 will be selected. Okay, and D3 will appear at output. So hence you can check that your multiplexer circuit is verified. Okay, this truth table is verified because you can check multiple data inputs are there with your control input A and B, but only one output is present at the Y. Okay, only single output. So as multiplexer, you know, multiplexer is many into one. Many inputs are there, D0, D1, D2, D3, but a single output Y. Okay, so that's all for today. So next we will discuss demultiplexer in a separate video. Thank you.